All right, it looks like we are finally live. First of all, I know it's been a long time, so welcome. It's always good to be back in the saddle, so to speak, and, doing some math problems, answering questions. I think I'd like to start off this live stream probably just by answering a few questions that people may have. Not necessarily related to math, but just kind of get settled in and maybe questions about where have you been? What's been going on? This channel's been around for over 10 years and it looks like you haven't been so busy lately. And the truth is I've actually been very busy lately, and that's maybe why the channel hasn't had as many videos as I'd like to put on there, Truth is, a channel like this is usually not my full-time job. Usually I'm working, teaching, making content for other websites, when it comes to math. I tend to be very active when it actually comes to making videos and making content, just not necessarily for this channel. But, I'm hoping to change that. That's why I started doing a few changes in the background that you may be interested in moving forward. Starting off with this live stream, this is really just kind of a test to make sure that all of my equipment is still up and good for streaming. And so far, it looks fine. It looks great. So that's always a good sign, which means I'll definitely be able to do more of these. A second thing, and this is probably a much bigger thing, is if you go to the website for MySecretMathTutor, it looks completely different than it used to. I was using WordPress until most recently, and I was having lots of problems doing errors and trying to get the code to work just right, which is kind of a thing that happens if you're into web pages and stuff like that. It's not a big deal necessarily, but when you don't have a whole lot of time to just dedicate your time on a website, it does kind of drain on you. So you can't do videos or focus on the math if you're sitting there fiddling around with the code on your website. And of course, people can't really organize or find the videos that they want if the website isn't up and going as well as it should be, So what I did is I completely nuked the entire site. I said, you know what, I'm having too many problems with these errors. I'm going to go back to something a little bit simpler and see if that works out a little bit better. So if you actually visit the website today, it again doesn't look anything like it used to. But hopefully moving forward, it'll eventually be a little bit easier to find those videos and maintain it moving forward, so that hopefully there won't be as many error messages, or if I actually do produce new material and decide to throw up on the site, it'll be a lot easier to find that stuff, so it should work out better for both of us. Also, the major changes, I used to design that site really with a desktop in mind, that people were going to be watching these on their desktop. And I think that just goes to show you that maybe I was behind the times a little bit. That's not really how people, well, I'm not going to say that's not how people view the internet. More and more people are watching things on their phones, and you really need to design sites with that in mind. So if you are on your desktop, great, it'll show up just fine. If you're on your phone, it looks fantastic. So hopefully the website will be much, much better on mobile than it ever has been before. So yeah, I've started to put my live stream on the website as well. So I think there was a countdown timer in case you're curious. Oh, and my calendar is up there. So if you're really curious when my next live stream is going to be, I'll start dropping things into that calendar so that, you can catch those. I'm hoping to do a lot more. I'd like to do like a Sunday live stream right before we hit the beginning of the week. I know that there can be a lot of questions moving into the beginning of the week, and I think that's like a perfect time to do it. And moving forward, we may even try and split these live streams into specific categories. If you have an algebra question and you really want to get it answered, well, maybe we'll just do an entire live stream just on algebra. I think that could be a lot of fun. Or if you're doing some differential equations and you're like, well, I want just questions on those types of problems, well, then, maybe we'll set up a live stream just for that particular category. I'm really open to where these live streams evolve and go forward. And I think there could be some fun things that we can do that maybe haven't been done before. We could, if you have a lot of people, let's say in your class, and you're trying to get a study session going, then why not let me know? I would love to drop into your Math 101 study session and just answer a bunch of questions. The best part about this is it doesn't hurt to ask. You can say, would you do this for me? It doesn't cost anything. I like doing the live streaming. So it's like, why not? The worst thing that can happen is I can say, oh, it looks like I might have something else at that time. I unfortunately can't do it. But the best thing that could happen is me say, yeah, let's do a study session. Let's spend an hour just answering your questions for maybe you and your class and go from there. So, again, I'm really open to where the live stream evolves and where we can go from here. Oh, looks like we finally have a few people that have joined us. Welcome. Good to see you again. Please, if you have any questions, you want to know anything, please drop it into the chat box. I'd love to see what you got. To pass the time until you have questions, I always got a lot of stuff that I'm kind of juggling around. I brought in my algebra book today because I was just kind of feeling like algebra. I also have various different websites opened if I want to search for any math problems online. That's okay too. Some of those can be a little bit trickier in terms of like the thought process that goes behind them, but I think it's all fun, so why not? Otherwise, if you're just here maybe doing your own math homework and you're just studying, that's okay. We'll find some fun problems to do and really go from there. All right, let's see what we got. So I found some various different study questions. I think these are from like SAT type questions. So if anyone's going into college or thinking about going into college, these are the types of questions that you'd go into. This is kind of a fun. This has to do with setting up equations. We kind of get into a mindset of solving, but this is all about how you actually set these up. So let me paint the scene for you, and we'll see if we can set this one up. This one says, Maria is staying in a hotel that charges $100 per night, plus tax for a room, at a tax rate of 6%. There's an additional one-time untaxed fee of $5, and that's charged by the hotel. So we're trying to figure out how to set this up if we're staying for X number of nights. Now, the fun part about this is I can see like the multiple choice answers, and it's not an actual number for the answer because we don't know how many nights Maria is going to be staying. So the idea is the setup process. How can you set this thing up so that it describes the situation no matter how many nights they stay? Well, you'd imagine maybe starting off with, let's say, X as the number of nights. So, good math problem, we've got to say what our variables are. I'm going to say X is the number of nights. And then we'll start combining it with our other information. So we know that this hotel is going to charge $100 per night, so that's what we essentially want multiplied by the X. So right now this is just tallying that part of the charge. Now the tax rate of this is applied to the room rate, and that's the 6%. So you could take this, and now you can multiply it by 0.06. Now you have to be careful if that's all you multiply it by, because that's not going to be the grand total for her entire bill. And the reason is you're only multiplying by that 6%. So you're going to make this a fairly small number when you're done multiplying these two things. If you want to make sure you include the original $100 or $100 per night, you can think of adding that on, or alternatively, you can think of multiplying by 1.06. Both of these really do exactly the same thing. That one, or adding on the 100x, is ensuring that the base price is also included in that grand total. So that looks pretty good. There was one more cost to this, and that was, of course, the $5 flat fee. We just add this on the end. Do a little plus 5, plus 5. And now this is good to go. So yeah, this would be a really good, fantastic algebraic expression. Now, what could you do with this thing? You could, let's see, I'm trying to think of, putting on my math teacher brain where I would use a problem like this. If I was wanting someone to solve an equation, I could say, hey, it looks like Maria spent let's say Maria spent $523. How many nights did they stay? Well, you would have to have this expression set equal to the grand total, and then you could go through a solving process for x. So, that's how, a math teacher would end up kind of incorporating this into a problem. Yeah, you may notice that I have some music going on in the background. That's just in case you are hanging back and studying. It's always kind of nice to have a little bit of music to kind of get your brain in the right mindset. I tend to prefer music that doesn't have any words. Otherwise, it distracts me a little too much. So if you find music that you like, that of course is copyright okay for YouTube, I'd love to add it to my list. All right, let's see what other things I can find in terms of math problems. And again, if you got some math questions, feel free to send them in. You can drop them in the chat. You can send them to my email. Either way is perfectly fine. Currently, I have the chat set to subscribers only. So if you want to subscribe to my channel, just hit that subscribe button. I'd be happy to have you on here. And then, of course, you can actually start chatting with me, and I can answer your specific questions. I do that because it helps cut down on the, I'm going to say, the clutter of the chat box a little bit. In the past when I've done these and there have been no restrictions, you just get kind of spammed by a lot of junk. So it's always nice that only subscribers can really take care of that chat box. But yeah, let's see what else we got. Oh, this looks like a fun geometric question. Let's see, I think I have my ruler here somewhere. This will work. So we're going to look at a diagram and then try and answer some questions about this diagram. I don't know what it is, but I think when it came to math and making diagrams, I always had a lot of fun. I'm not the most artistically inclined, not by any means. But I always thought this was fun. If we were doing a word problem and we had to draw something, this always just felt fun. All right, so this particular drawing is not to scale. That's the important part for a lot of these study type questions is you can't necessarily eyeball them. They try and make them fairly accurate, but we don't necessarily want to trust them. And they really make them so that they're not perfect, so that you can't trust your intuition. They're really kind of forcing you to trust your math brain a little bit more. So let's see. Here's the diagram. What do we know about this diagram? Well, we know a few things. We know that triangle ABC is similar to triangle. This is EDC. And the big question is, if I know that these two triangles are similar, then what information can we really pull out from that information? First of all, let's highlight these two triangles just to make sure we're on the same page. So I got ABC. That'd be this upper one up here. I'll do that in blue. And we'll do the other one, that's the EDC. We'll do that one in green. So the claim is that these two triangles are similar. Now you can definitely tell that my diagram is not the most accurate. If you were to cut one out and paste it on top of the other one, those lines aren't going to be perfectly parallel like they should be, but that's okay. That's okay. Again, we're not relying on our intuition. We're relying on the information that they've given us that these two triangles really are similar. So if they are similar, what does that really mean? What does it mean to have triangles that are similar? Well, in a nutshell, it means that there are corresponding angles that are the same. The sides don't have to be the same, but they have to have these pairs of corresponding angles that are the same. So let's start to mark out what those angles would be. First of all, just because we have these two angles in here, I know that those are going to be the same. Let's see, I'll use some double lines. Those two angles are also going to be the same. 1, 2, 3. And these angles are also going to be the same. Okay, so that just comes from the information of having two similar triangles. Now, what this really reveals in our diagram is that these lines that I've drawn, there's something more special about them, and that my diagram is not really accurate. I'm going to try and extract out of this diagram exactly what I'm trying to say. Yeah, let's see if I can do it just a little bit off to the side here. Maybe I'll do this in, yeah, I'll do that. Imagine this as a smaller version, but I'm kind of extracting out just the stuff that I want you to see. So we have this point B over here. That's where our angle is. We have another angle. Well, I guess technically that angle would be ABC. And we have another angle down here. This would be CDE. I'll just mark it as D. So if we really have these similar triangles, then what you're seeing is it's forcing these two angles to be exactly the same. And if they are exactly the same, then we have this line cutting the other two. We're going to get a set of parallel lines. Specifically, we can say that AB is going to be parallel to DE. And that's really just kind of tracking down those angles to make that conclusion. Now, that's not the only pair of angles that you can really use to make that conclusion, but it is the one that I saw the first, so I just kind of used them. You could also use these two angles, that'd be BAC and CED. Those are also the same, again showing that you have a pair of parallel lines. I think this is a really good lesson for, I don't know, anytime you're working with geometry in general. You kind of want to kind of lay out all of the information you're given and then kind of unpackage things. If they tell you that a triangle is a right triangle or a similar triangle, you have to kind of think back to the definitions of what those are and then include that information in here somewhere. And in a way, it kind of chains itself to other bits of information, and you kind of get more and more, and then you can actually start making some conclusions. It's kind of like the whole mindset that we have, whether we're working with geometry or trigonometry, in that you start off with this basic premise, and then you start building some more conclusions from it. I think that's why when we're looking to teach concepts like proofs and reasoning in a mathematical sense, they will often turn to these topics of geometry and trigonometry because they're very visual, but they just lend themselves to unpackaging these definitions so well. And in a context where you might not use these definitions as much as you do the algebraic ones. Excellent. If you're just joining us, welcome. We're just sitting down answering some questions, just seeing how things are going. And of course, if you do have a math question, feel free to drop that in the chat box. Yeah, if you're just joining us, I did want to remind everyone that I've been having fun reworking the website. So, if you want to go check it out, it's a bit of a mess right now. I will fully admit that. There's a lot of links that simply don't work, but I'm getting there. It's a process of, if you're going to take the old website and completely just wipe it clean, it takes a lot of work getting one of those things back up and running. But the fun part is you do kind of start with a blank slate, and it's what else can I do with this website? And that's always enjoyable. Oh, so if you have any suggestions, I'll also take those. Yeah, for sure. You know that I'll definitely have some future live streaming sessions. Yeah, and I'm hoping to put those on the website as well. There's a placeholder that I have for doing the live streams. It's just a matter of making sure that I can update those, which I think I can. If I can throw it in my if I can throw those in the calendar and stay on top of them, we can definitely have more live sessions just like this one. Oh, you are most welcome. Yeah, thanks. Good question. This question says, how often will I probably be doing live streams? I would like to have at least like 3 a week, but it all depends. You know, if there's a lot of demand and people want even more live streams, then I got the time. Yeah. One thing that has really motivated me to kind of work on this channel a little bit more is, unfortunately, I am no longer working as an instructor or working as a content creator anymore. It was nothing bad. It's just that my position got eliminated. So currently I'm actually unemployed, which, you know, kind of sucks. It really does. I'd really like to be working again. But the good news is that I really do enjoy doing math. So in the meantime, you know, if I'm not working in a professional setting, then yeah, I'm going to continue doing math. I'm going to continue helping people. That's what I love doing. It just means that you'll see me on live streams a lot more. Yeah, this says, I didn't even know that you live streamed. I do. I just didn't used to do a whole lot of live streaming because it was, you know, time consuming and I was making a lot of other content in other places. But yeah, moving forward, yeah, you're definitely going to see a lot more live streams. So feel free to send in your questions and get some help. I like to think of this as, you know how there's private tutoring, you can get like one-on-one help with a private tutor and it costs you a lot of money. This is public tutoring, so it doesn't cost you a darn thing. You know, just your time to ask questions, and of course I have fun going through them, and hopefully we both get something out of it. Excellent, excellent. Let's see if we can find maybe just one more question. Maybe I can get some space on here. All right, looks like we're doing, ooh, I'm gonna throw this into the pre-calculus section. Only because it is a solving type of problem, but it looks like it's a little bit more difficult. You may not see this in algebra per se, but I could see this showing up in a pre-calculus for sure. And this one is all about solving a system of equations. So let's get this on the board. I'll give you my initial thoughts on it, maybe even time for you to think about it as well. And then we'll go from there. Okay, so this is a system of equations because we have 2 or more equations. And if we're thinking about the shape, what does this really look like? This represents a circle and a line. So even before I actually get into the solving process, it's really good to get a sense of what this looks like geometrically. I'm going to draw a few. We could have the circle with the line going through it in a couple of points. This would give us 2 solutions. We could have a circle just kind of barely touching along one side, so it might only have 1 solution. And of course, there is that possibility that the line does not intersect the circle whatsoever, in which case we'd say that it has no solutions. It's good to have that stuff in the back of your mind, because when you're in the mud of the solving process, if you somehow come across like 5 solutions, that's a red flag that you've gone off the mark. But also, if you come across, let's say, 2 solutions, or 1 solution, or no solution, you can kind of take a step back and say, like, yeah, that's not completely unreasonable, because these are the things that could happen geometrically. Right, so we don't really do much with that other than just kind of keep it in the back of our mind as we start moving forward. If we really want to solve this, this is currently set up in a really nice way to do a substitution. I say substitution because if we really look at that second equation, it already has the y part completely isolated. So we can take that and immediately drop it into the first equation. So I've just taken every instance of y and put the negative 4x in there. And now we have a single equation that only has x's in there. Now let's go from here, okay? So I would want to maybe get rid of those parentheses. Negative 4 squared would give us a 16. And then I could go ahead and combine these. I have 1x squared plus 16x squared for a grand total of 17x squared. Anytime I'm combining like terms, I don't know why that it is, but when I think of like terms, I almost think of replacing the variables with something else just to kind of get my mind in the right sense. You can do this too if you're doing like terms. So even though I said x squared when I was reading that last line, I almost think of it as carrots. Carrots, 1 carrot plus 16 carrots. If I put them together, I'll have 17 carrots. And the carrot's just a placeholder in my mind for x squared, but it works the same way. It recognizes those like terms. All right, let's go from here. I need to divide the 153 by 17. I don't know what that is off the top of my head, so let's see. 153 divided by 17. Looks like 9 is the answer. So I have that x squared is equal to 9. And we'd essentially have one more step. We would take the square root of both sides. And here's where we have to be just a tiny bit careful on what we get out of this. If we take the square root of something that is already squared, we actually get a plus minus. So in this case, we have like 2 possible solutions that x could be. X could be a positive 3, or x could be a negative 3. And this really shows where kind of that prep work plays a part. It's kind of looking like there's a couple of solutions, so that's okay. That's in the realm of possibilities. It might be just a line cutting across a circle in 2 different spots. That's okay. Right, now that we actually have 2 values for x, let's go ahead and drop this into our second equation and get both our values for y. Let's see, I'm just going to rewrite this. So I know that y equals negative 4x. Yeah, let's put in the first one. So y equals a negative 4 times a positive 3. So this would be one value for y would be a negative 12. Or I could say that y equals negative 4 times a negative 3. This would give us a positive 12. Taking the proper pairs in here, we could think of our solutions. So one solution would be this particular pair where x is equal to 3 and y is equal to the negative 12, and the other solution is x is equal to the negative 3 and the positive 12. And there are both of our solutions in this. Not too bad. Yeah, and again, it's really just showing that, yeah, this line really does cross the circle in 2 different spots. Very nice. I'm just double checking to make sure everything's all good on the streaming side of things. If you have any questions for me, feel free to send them in. Or if you're just sending well wishes, I also appreciate that as well. I think that's probably one of the most fun things about doing live streaming or a YouTube channel in general, is actually just reading all the comments. So feel free to put them in. I do read them all. No, I do have a little bit of a backlog. But eventually I'll get them. I like putting little hearts next to them. That's always a lot of fun. Oh, let's see. I wonder if there's a way. There is a way. I just realized that I can put a poll out to anyone that's watching. I think it's a lot of fun. Gets a little bit of feedback. This is just a quick poll to experiment with it. It says, hey, do you want some more live streams? Yes or no? You have selected. That way I know if you like live streams. Of course, I'm still going to be making like regular videos, but it's kind of fun to do these live streams as well. You get live questions done. Cool. Let's see what else we can find here. Oh, excuse me. Let's see. I'm just on the Math Reddit website to see if anyone has any questions. Always kind of fun to grab those. These are solved. I want some unsolved ones. I want some ones that no one has touched yet. Oh, let's see. Looks like we have some interest rates. What else we got? We got an induction problem? No, that's solved. Oh, that looks like a linear, what is it? A linear programming problem. Got some matrices. Oh, here's a fun one. Absolute value. Yeah, all right, let's see what we can solve about that one. I'm going to switch back to algebra. Let's clear this board here. let's see what we can answer about it. So this one starts off with a nice algebraic expression. So I have the absolute value of t plus 3 is less than or equal to 2. And our goal for this one is to do two things, where we want to find the minimum value and the maximum value. So min and max. Now, in a problem like this, it's important to point out that it's possible that there is no minimum value or maximum value. So what we're really doing here is trying to figure out, what values could go in here, but we might only find a minimum, or we might only find a maximum. So you do have to be careful as you're moving forward, and you get questions like this. Let's see what we can do in terms of putting in values for, or I guess visually representing this. Maybe that's a better place to start. I'm just going to draw a nice little XY axis here. And I'm going to represent all of the places where this is equal to 2, and then we'll do the less than or equal to 2, so we get an entire region on here. So if you're following along, what I'm really doing is I'm graphing this as an equation. I'm graphing it as the following equation. I have the absolute value of t plus 3. I'm going to move that t2 to the other side. And I'm graphing it as a y, so I'm in the ty plane. Normally, with an absolute value like this, you'd get this nice little V shape. But the plus 3 and the minus 2 are going to do a couple of things to it. The plus 3 is going to take it, and it's going to move it to the left 3 units. 1, 2, 3. And then the minus 2 is going to move it down. 1, 2. So that new corner sits right here. We're going that way. We're going that way. Everywhere on this line represents where it would equal to 2. Since we're dealing with an inequality, we're essentially going to look at some sort of region. Yeah, either below this line or above the line. This one is going to be, let's see, what is it going to be? I think it's going to be below, because if we were keeping track of this inequality symbol, it would say that y is less than or equal to, is that right? Let's see, if that was the original inequality symbol, I move the 2 over, yeah, then this would be a less than or equal to, yeah. So essentially you would shade in everything below this nice little V shape. If you're stuck with a question like that, what I tell people is you just test, you throw in a point. You say, well, we'll test one point on one side, test one point on the other one. If it works out, then that's how you know you're shading on that side. So if we're unsure, let's just throw in something like 0, 0. And what you're checking here is you're checking to see if the inequality is true or not. Does this make sense? And actually, what? I'm going to throw it in the original. The 0 plus 3, is that less than or equal to 2? So 0 plus 3 is 3. Then I take the absolute value of 3, which is 3. I'm determining, is that less than or equal to 2? The answer is no, so I know that 0, 0 is not an included point. Yeah, it actually looks like we're shading above. Cool. Now, the overall question of this is to find the minimum and maximum values for t. And I think what this really shows is that you could have some fairly large values for t, and it's still going to be able to satisfy this inequality. Though, let's see, if we're trying to solve this, well, I guess in the original there is only just a t. We could, we could solve this directly. I don't even need to do anything like graphing. You can think of this as either a plus or a minus. And then we can solve these as separate problems. So I either have t plus 3 is less than or equal to 2, or negative t plus 3 is less than or equal to 2. So t is less than or equal to negative 1. You know, if I subtract the 3 from both sides. This one, if I move the negative to the other side, I'd have to flip around my negative sign. Then I could subtract. I'd have that t is greater than or equal to negative 5. So, what do I have? What do I have for an answer? It shows that t is less than negative 1. Or negative 1. Or greater than negative 5. Oh, I got a nice little range of things. So negative 1, negative 5. Shade everything in between. So it looks like the minimum value is a negative 1. The maximum value is... Oh, I got those backwards. The minimum value is a negative 5. The maximum value is a negative 1. And that'd be our two values. Cool. All right, it looks like I'm about at the end of where I want to be for today. Thank you for joining me. If you decided to just stop by and check things out, again, in the future, I hope to do more live streaming and, of course, put out even more videos that will hopefully help you as you're doing your math. This was a lot of fun. Hope to see you again. Otherwise, you have a fantastic day. Thanks for stopping by.